Hi everyone, this video is on mixed exercise 14 question 10. So the points P and Q lie on the curved equation y is equal to e to the power of half x, and the x coordinates of P and Q are len 4 and len 16 respectively. So in part A, we want to find an equation for the line PQ. Right, so these types of questions are very common in AS exams, for year 12 exams basically. And in this case, so to find the equation or an equation for the line PQ, we basically need to have the coordinates of P and Q and also the gradient so that we can use the formula y is equal to mx plus c or the other formula to find the equation of the line. So first, let's find the coordinates of P. So we know that the x coordinate of P is len 4. So to find its y coordinate, we just substitute len 4 into y is equal to e to the power of half times len 4, like this, right? And now remember that when we have len is the inverse function of e, so when we have this is basically the same as, because e and len cancel each other out, so we simply get half times 4, and that is equal to 2, right? So there are multiple ways of looking at this, but the way that I did was kind of looking like, so we have e to the power of len 4 times the half, so e and len cancel each other out, and then therefore we just have basically one, sorry, not one, and then we'll have 4 times the half, which gives us 2. Also, we could have used the power law of logs, because in that case, we can basically rewrite this as len 4 to the power of half, and e and len cancel each other out, and we'll have 4 to the power of half, which is just equal to 2. So that's another way of looking at this. Anyway, so for the next point, which is Q, so here the coordinate is to the y coordinate. Now for Q, the x coordinate is len 16, and we don't know the y coordinate yet, so we just substitute that y is equal to e to the power of half times len 16. And in this case, the answer is equal to 4. So now these are the coordinates. So now that we have the coordinates, we need to find the gradient first. So to find the gradient of the line PQ, we do change in y over change in x, which is something from GCSEs. So we can do 4 minus 2 len 16 minus len 4. So we get 2, and then len 16 over 4, which is just 2 over len 4, and that's the gradient. So now that we have the gradient, we can use the formula y minus y0 is equal to m times x minus x0. So in this formula, remember that y0 and x0 are just the coordinates of the point, and then m is the gradient. So we just substitute. Let's substitute the coordinates of point P. So y minus len 4 is equal to 2 over len 4 times x minus, actually it's the y coordinates of P is 2, so we have y minus 2 is equal to 2 over len 4 x minus len 4 now. Right, so this is the equation, and we can simplify this now. So we have 2x over len 4, and then we get just minus 2 plus 2 on the other side. So the equation becomes 2x over len 4. It's len 4. So this is the equation of the line PQ. Now that we have the equation of PQ, so that's the answer to part A, we want to show that the line passes through the origin O. So this part is actually very simple, because the equation is equal to 2x over len 4, and therefore its y-intercept, or the value of c, is just equal to 0, right? And whenever the y-intercept is equal to 0, that just means that the curve or graph passes through the origin. So that's very simple. So since the y-intercept is equal to 0, the graph therefore passes through the origin. And finally, part C, calculate the length to three significant figures of the line segment PQ. Right, so in this case, we just use the formula of the distance or the length of a line segment, which is basically equal to, so let's say if we want to find the long segment PQ, so we do y squared minus y1 squared plus x2 minus x1 squared. So you just now need to substitute the coordinates into the equation. So length 16 minus length 4 squared plus 4 minus 2 squared. And yeah, so you basically get length 16 over length 4 squared, and then here is just obviously 2 squared, and the answer to three significant figures is equal to 2.43.